everyone, here we are looking at proportional graphs, topic 2-2. Yesterday we talked about looking at proportional relationships and tables. Now we're going to be taking those tables and either creating a graph or looking at a graph that's already created for us. In this box here is our key concept. It states that a graph can also be used to show a proportional relationship between two quantities. So again, yesterday we talked about a table being one of those ways, and now we have a graph. A graph that represents a proportional relationship is a straight line passing through the origin. This is the main key concept of today's lesson. This is, I believe you talked about last year, talking about straight lines and graphs. That's the main focus of today. That it's going to be a straight line and it travels through the origin 0, 0. So these next couple examples are complete for us. They're just a good way for us to double check that we understand how to interpret that previous sentence. It says, does the graph show a proportional relationship between x and y? Clearly looking at this graph, I don't see a straight line. So the ratio of x and y is not the same at every point on the line. Because it's not a straight line, what they're showing you here is at the point 1, 1, and I would add this in because I don't think they did a great job. This is the point 1, 1. Remember, this goes x and then y. They're saying that the ratio is reduces down to 1 first. When it's 2, 4, and your x and your y, over here, 2, 4, that as actually when we write it as y divided by x is 4, 2, or it reduces down to 2 over 1. Since these two ratios are not equivalent, the graph does not show a proportional relationship. It also continues to say the graph is not a straight line that passes through the origin. So no, the graph does not show a proportional relationship between x and y. The following example says, does the graph show a proportional relationship between x and y? And looking at this graph, it shows clearly that the graph does not pass through the origin. It is passing over here, it's touching the y-axis at 4. It does not pass through the origin, and since that, it does not show a proportional relationship between x and y. Number 1, I'm going to sound like a broken record. Does each graph show a proportional relationship between x and y? I'm just going to let you guys go ahead and do this. Pause the video. And I would say that was pretty self-explanatory. A was the only one that does show a proportional relationship. B is a straight line, but it does not pass through the origin. And C is clearly not a straight line. Number 2, they're asking now, does the equation of y equals 6x show a proportional relationship between x and y? So this one's a little bit different because it's not saying does the table show a proportional relationship and does the graph show a proportional relationship. It's asking does an equation. What we're going to practice right now is creating a table from our equation and then graphing the points to see if it shows a proportional relationship. So how I set up my table is I always have my x coordinate on the left side. I like to then write the equation, and in this case it's y equals 6x, and then I'm going to write what my y is going to be. I kind of explain it to myself as I'm going to figure out what values I want to put in for x, something's going to happen in the equation, and my output will be my y. I'm just going to use the numbers 0, 1, 2, 3, 4 for my x. Some of you might be wondering where I got those numbers. I am choosing those numbers because when I look at the graph that is set up for me, I don't have any negative values of x, so it doesn't make sense to use those. I want to definitely check to see if it goes to the origin, so I wanted to check if it's 0 at x, and I didn't really, if I go up too large, then my graph is going to be maybe, I have to enlarge it differently. So what I'm going to do is for the first coordinate, I take this 0 and I substitute it in place of the x. Sorry. So I'll have y equals, well, what's 6 times 0? 0. Then I'm going to take and substitute now the 1 in place of the x. So it's 6 times 1. 6 times 1 will give me 6. Then I will do 6 times 2 to give me 12. 6 times 3 to give me 18. And 6 times 4 to give me 24. And I just have 1, 2, 3, 4, 5 points there for x to practice. So now, these are my coordinates, 0, 0, 1, 6, 2, 12, 3, 18, 4, 24. So I'm going to plot, well, I have to first label my axes here. I have my 0, and x went up by 1, 2, 3, 4. If I look at my y values that I got, you notice that they just keep going up by 6. So one box on the y-axis is going to be worth 6. So 6, 12, 18, and 24. It's okay if your x-axis and each box is worth 1 and your y-axis is worth 6. They don't have to be equivalent there. So I plot my points, 0, 0, 1, 6, 2, 12, 3, 18, 4, 24. Connect my points, draw an arrow, and does this show proportional relationship? Yes. It is a straight line. Passing through the origin. Moving on to example number 3, they're asking, does the equation y equals 4x plus 1 show a proportional relationship between x and y? So again, I'm going to set up my chart because I noticed they didn't even give me a graph this time. And then I will have y equals 4x plus 1, and then I will write down what my corresponding y is. I'm going to obviously substitute in 0 because I want to check to see if a graph goes through 0, 0, which is the origin. If the point 0, 0 does not show up in my table, then the relationship is not proportional. So when I substitute in here y equals 4 times 0, order of operations says to do the multiplication first. So 4 times 0 is 0, plus 1 gives me 1. Since my coordinates would now be 0, 1, that does not pass through the origin, so y equals 4x plus 1 does not show a proportional relationship. No. The line would not pass through the origin. That doesn't mean that it wouldn't necessarily be a straight line, but since it doesn't go through the origin as well, it's not proportional. Number 4 is reminiscence of the purple paint shade that we had yesterday. It says that the manager of the car paint company prepares orders for its Granny Apple Green paint. Tell how the graph can help you find the amounts of blue and yellow paint needed to make 8 gallons, 24 gallons, and 56 gallons of Granny Apple Green paint. Now I know that to make yellow, or to make green, I need to use yellow and blue, which they have also labeled for me on my graph, yellow and blue. Yesterday we talked about proportional relationships. We're setting a proportion here from the table to help us figure out how much paint that we needed. Here, they're telling us when we have 3 gallons of yellow, so I'm going to start at the 3 and go up. When I hit the line, how many gallons of blue is that going to give me? 5. So 3 gallons of yellow plus 5 gallons of blue, doesn't that give me a total of 8 gallons? Not total, which is my green paint. What if I went up, if I had the ratio of 6, and when I hit the line, I get 10. Well, 6 plus 10 is going to give me 16, and that's not 24 gallons. So let's try 9. I go up to the line, I hit 9, and then I have 15, and 9 plus 15 is 24. So the ratio would be 3 to 5 for the blue, yellow to blue. 3 to 5 would give me 8 total. 9 to 15 would give me 24. And then now I'm looking for what to what will give me 56. Well, I know that 12 plus 20 would give me 42. 15 plus 25 would give me 40. 18 plus 30 would give me 48. And then 12, no, that's a backwards number. 21 plus 35 would give me 56. So there is a proportional relationship that if I was to say 21 to 35, wouldn't 21 35ths reduce down to 3/5 in a simpler ratio? So number 5 says that the graph shows a proportional relationship between time and the distance run by a cheetah. Time, notice, is in our x, and the distance is in the y. This is not a multiple choice question. There are 4 parts to this question that they want us to answer. They are saying, what does the point 190 represent? Well, let's remember that our coordinates are always written as x, y. So 190. Well, 1 on the x-axis represents time, and 90 on the y-axis represents distance. So it's really time in seconds, distance in feet. So really, isn't it 90 feet per second? That's the unit rate that they're giving us here. What does the point 0, 0 represent? That they'll go 0 feet in 0 seconds. How far can the cheetah run in 3 seconds? If I go to the graph, I find the 3. I go up until I hit the line, and then I go over. The corresponding y coordinate to the x coordinate when it's 3 is 270, so you would go 270 feet. And then it says, assuming that the cheetah continues to run at the same speed, how long would it take the cheetah to run 900 feet? Well, I can set up here, if it's a unit rate of 90 feet per second, if I set up a proportion, they are saying he runs 900 feet, so the 900 feet would go in the numerator because I'm setting things equal across from each other in a proportion. I'm looking for the time. How do I go from 90 to 900? I would multiply by 10, so I would multiply by 10 on the bottom as well. So I would say 10 seconds. I'm going to have you try number 6 on your own. When you come back, the answer will be there. The question wanted us to know where the unit rate, which point would represent the unit rate of the fruit to the nuts. So you have to think about, you're looking really for the fruit to the nuts. We're looking at the y first and then the x coordinate. So I'm looking for my x coordinate to be 1 in order for this to be a unit rate. So I have to go down to 1 on the x-axis, draw my line up until I hit the line that is graph, and I go over and I see that the y coordinate will be 2. So it is not 2, 1 for the coordinates. You have to notice that when it's x, that 1 is x and 2 is y, so your coordinates will actually be 1, 2. Okay, thanks for watching. We will see you tomorrow.